Okay, so here is the example for the calculus volume section using using washers to find your volume. Okay, so the example given is going to be a set of two curves, to where the first curve is going to be a cosine curve and the lower curve is going to be a sine curve. So this is cosine and this is sine. And this is your area, and you're going to be revolving around here. This is your axis of rotation, is your x-axis. And so to find this volume that you're going to be getting from these two curves, you're first going to want to find where this intersection point is, and as it turns out to be, it's actually at pi divided by 4 is where they first intersect, and your 1 over here is going to be 0. So that's your a, and that's your b, and so you set up your integral from 0 to pi divided by 4. And so now we have to think of it as pi capital R squared minus pi lowercase r squared. And so now we just move on to the next step, to where you still have the same interval, but now you are taking these you're taking these values of r, and you are going to be, my first step is I'm going to separate this pi out so that it's just simpler here in the bottom, but you're going to take this capital R is cosine x, so cosine squared x, and minus from sine, or you're going to subtract sine squared x from that, and then you get dx, and you add that on to the end. And so from here you will move on to just simplifying this as a integral. You just solve it normally as an integral from here. So your next step after that is going to be to use the cosine sine identity for trigonometry, to where if you subtract cosine squared if you subtract sine squared from cosine squared, then you're going to get cosine of 2x. So this just becomes with pi on the outside and cosine 2x here. And then so this is going to become pi of sine 2x over 2 pi divided by 4 is equal to pi divided by 2 units cubed.